In the process of methanol production, a gas stream flowing at a molar flow rate of 100 moles per minute containing 32 mole percent of CO, 64 moles of H2 and 4 moles of N2 is fed to the reactor. The product from the reactor is condensed while liquid methanol is separated. The unreacted gas are recycled in a ratio of 5 to 1 mole of cycles to moles of fresh feed. The reactor contains 13% of nitrogen and parts of the recycled gas are purged. Calculate all the unknown stream flow rates and composition. So this one is these two are your gas and it forms CH3OH, which is methanol. So how are we going to draw the process? This is how the process flow diagram looks like. So you have a feed with 100 mole. In here we take 1 minute as a basis. So we have 100 moles of fresh feed that goes into the reactor. But after the reactor reacts, it goes to the condenser. The condenser will then separate the methanol out, so you have a product P here. And the distillate, which contains the gas, goes up. Part of the gas are being purged and part of it is being recycled back. Now, why we have to purge our gas? It is because when we recycle, you also have N2 here. The N2 does not react, so we have to purge it out to avoid accumulation. If not, we will keep on accumulate over here and the overall process will become unsteady state. So the feed contains CO, H2 and nitrogen, which are given. We have the molar composition over here. The reactor feed, we are given that the reactor feed contains 13 mole percent of nitrogen and that the recycled stream and the fresh feed is at a ratio of 5 to 1. Product only contains methanol and purge, we also have this. So first, we are given that the recycled feed and the fresh feed is at a ratio of 5 to 1. So since our basis of fresh feed is 100 mole, therefore the recycled stream is actually 5 multiplied by 5 moles of R per mole of F. And we know that R is 500 moles of R. So R in total is 500 mole. The reactor feed is the combination of F plus R. So F plus your R gives you your reactor feed, right? You mix one part here, and the total is your reactor feed, which gives you 600 moles. Write it down. Since, okay, we know we have this value, this, and this. We have these 5 information. Therefore, we can do material balance using the nitrogen because we have the most information of it. So the nitrogen in the feed, in the fresh feed, plus the nitrogen in the recycled stream will give you the total amount of nitrogen in the reactor feed. Okay, so nitrogen is 0.04, which is 4%, multiplied by the feed, and this one we don't know, this is our unknown, multiplied by R equals to 13% of nitrogen in the reactor feed. Substitute your values in and we can find the fraction of nitrogen in the recycled stream is 0.148. Now, the mole fraction of the species, which is CO, N2 and H2, are all the same at R, G, and D. R, G, and D. The composition here, meaning the fraction here and here, should be the same. Why? Because whatever comes out here, it's just being split. Like you pour, for example, you have a full glass of milk and then you want to pour it into 2 small glass, but the amount of composition in there is still the same. You're just splitting it in half. So the composition are the same. Therefore, this one we found that it is 0.148. So this one over here is also 0.148. As so. Next, since inerts are non-reactive and are unwanted species, we need to have a purge stream, like I said, G, to avoid accumulation. So the inerts here is N2. It is totally not being reacted. So the nitrogen from the feed should equal to the nitrogen in the purge stream. Same, multiply your feed with 4%, which is the composition of N2, equals to, we know this already, right? 0.148 multiplied by G. Then we can solve for G is 27.03 mole. We can now do element balance based on the overall system. The number of moles of CO that goes in, so the overall system is here. We will look at here, this one and this one. 1, 2, 3. In, out, out. The number of moles of CO in F, so element balance, like I said, C, you only have 1 C per mole of CO. And what comes out you have that contains C is CO. And in the product stream, you have C as well. It is only 1 mole of C per mole of methanol. So the number of mole of CO in the feed is its fraction multiplied by F equals to the fraction of CO in the G stream multiplied by G plus P. Put the values in and we have equation 1. Next we can do element balance for H. So for H, what goes in is we have hydrogen in the feed that goes in, hydrogen in the purge stream that goes out, and we have 1, 2, 3, 4. We have hydrogen that comes out in the product stream, in the methanol stream. So over here we have 4 moles of H. So don't forget to count the H over here. Substitute the values in again. Simplify it, and then we have equation 2. Solve these two simultaneously, and we can find that X, the fraction of hydrogen in the purge stream is 0.568, and P is 24.3 moles. And 0.568. Okay, so this one is the same, right? The purge stream and the recycled stream share the same composition, 0.568. And to find this, how are you going to find this? Simple. Just take 1 minus this and minus this one. So take 1 minus the fraction of hydrogen in G minus the fraction of nitrogen in G, we should obtain 0.284.